Now let us check how to simulate our AND-gate program in Quartz software. So double click Quartz software on the desktop. So double click. So the environment will open here. So here we can select a new project wizard. So as you select the new project wizard, it will prompt us to go through the introduction. It is going to help us to create a new project with the following settings like project name, name of the top level entity, project files, libraries, and EDA tool settings as well. Then select the next one. By selecting the next, you can get into the next window. So here I create uh, a directory inside the given working directory. You can create it in anywhere, either in C drive or in a D drive. You can create. And now I just wanted to name my directory as and underscore demo and underscore demo. And the name of the project also, I just keep it as it is. So and underscore demo, I will give it. So what is the name of the top level design entity for this project? By default, it will take whatever we type for the type, project that same will be appearing here. So let us also follow this. Then you can select next. Next, when you click, it asking you to confirm. It is the particular directory is not does not exist. So do you want to create it? Then you can select yes for it. So click yes. So new directory will be created in the my computer. And then now you can select the project type of project to create. Either it's an empty project or a project template. So you can select an empty project. So as you select the empty project, then we will go through the subsequent steps. If you have already the source file, no, then you can add this file here, but later we can discuss about it. So we'll just skip this now by selecting next. Then here you are prompted to select a family, device and board settings because the target board has to be identified here. So we are targeting the uh, program to program FPGA. So we have a different types of Intel FPGAs are there, and here we can open it and we can see the different family. And basically we have the Max 5, Max 2, Max 10, Cyclone, Cyclone 4 like that up to area. We are supported by this Quartz Lite version. So here we select the Max 10 device. So as we select the Max 10 device family, in that family, a particular device, no, which is by default, it is selected here. So let us go with the same thing as we are not going to download the program onto the kit now. So select this as a the whatever that comes in default that we can select it. So the details of this device also it's given here. You can go through it. Then you can select next. As we select next, it is asking us to specify EDA tools that we are going to associate with the Quartz Prime software so that we can select it here. Later also you can select it. So now we can select next. So we are about to finish our creation of new project. So here this gives the summary where it gives the project directory and also it gives the name of our file project name and what is going to be the top level design entry and what family we have selected, what device we are targeting for. All these details are going to be summarized here. Then you can select finish. As select finish, many changes will appear here in this layout. So as the process is going on inside, so it will in project navigator we will get our project and top level module that is and underscore demo and the subsequent task that can be performed on this particular top level module also it is going to be listed here. So now what we do, we create a Verilog file. So we create a Verilog file by selecting this new icon. So here it asking us to select what type of file we want to create. So you can select the Verilog HDL file and click OK. So as you click OK, then we will get a text editor here. So in the text editor, we can type our program. I just put a comment line. So it's a Verilog code for uh, to input and git. Okay. Then I can just type my program here, module. If you want, we can zoom in. If you want to zoom in, we can go to options and we can set up the font size. Okay, so the text editor color font size is there. If you want, you can make it to some around 14 just now, so that will be easy for us to view. So module, and I name this module as and underscore uh, not two. Whatever the top level module name we are given, the same name we'll use and underscore demo. Then we can select output. Output I call it as a Z. Then input I make it as A comma B and terminate it with a semicolon. Then I use a gate level primitive now. So and then the label for this primitive, I just call it as a and underscore D is the label for this primitive. And now first we give the output, then followed by the input A comma B, and we can terminate the thing with a semicolon, line with a semicolon. Then finally write a statement, end module. So once you press enter, that will be changed to the blue color. Yes, that is done now. So next we'll save the file immediately. So as you save the file, it's prompted to save you with extension Verilog HTL. So we just save as a type and it is selected to Verilog. So now we select it, save here. So as you save and also there's an option add file to current project. So the current project, the file will be added. Okay, so that is added now. So file is also saved here. Next, we need to check for any errors. The synthesis, we have to check for the compilation. Compile and check is there any syntax errors or not. So for this, you can select the file and you can um, expand this analysis and synthesis. There we can find out there is an option called analysis and elaboration. Analysis and elaboration. Double click on this. So as we double click, it goes through some process and progress also it's being shown here. So we'll just wait for the process to complete. So 4% completed. So initially it may take some time, but it will get over soon. So now it is completed. Analysis and elaboration is completed. Next we go to, we'll verify. Before we do any of the work, first let us check it out whether it's going to work as an AND gate. For this, you select tools and select run simulation and RTL simulation very particularly. So you can select the RTL simulation. So now it is prompting us to select what simulation language that you're going to perform. So we're going to perform on Verilog HDL. So select it. OK here for a Verilog HDL. So as you've done this, it's going to uh, perform a simulation. So once again, we'll click it here. So run simulation, RTL simulation. Then as we do this, it will open another software called Model Sim will be opening here. So that will open. Once you open here, where we can do it. So it's taking some more time. Let me invoke it for one more time. Let me check it out. So yeah, so it's open here now. Yeah, it's giving some error here, right? So what error? Technology, in addition, model utility, and error failed to access library work at RTL underscore work. Okay. So once again, we will rerun this because twice it is open because many times we have clicked it. So we will close everything and we will open it once more time. Okay. So as we open now, oh, now once again, I'll open it here. The same procedure only run window RTL simulation. So just wait for the model sim software to get invoked. So now this gets invoked here. You can see that here. So you can open this. Now there is no zero errors at all. So here what we do, we want to maximize. You can maximize the screen Once the screen is maximized, then we can select the library here. In the library, there is an work folder. You can expand this work, and that gives you the module, what module that we have selected here. Then right click on this and underscore demo, then select simulate. As I select the simulate, it goes through some changes. Then finally can look into it objects. Here we can see our signals are added here in the objects. So what do I do? I take all these three signals and right click on this and go to add it to wave. So as you add it to wave, it gets added to the wave here. And here in the conveniently we can move the variables up and down. So for me conveniently I keep the output at the bottom and inputs at the top. Then here to check the functionality, we right click on the A variable and as you right click, it will give us an option to force the value. So here we force the value. We set the A value 0. By default, it's a high impedance. Then next, we also set the B value uh, 0. B value 0 because first condition is going to be 0, 0. Now let us run this code and check. So here we have a run option. It's going to run for 100 picoseconds. So you can run it here. So 100 picoseconds run. Now if you place a marker on this output, we'll be able to see A is 0, B is 0 and Z is also 0. Now we'll change only the B to 1. We'll change the B to 1. As you change the B to 1, we will be able to see the changes on B and also the response for that on uh, Z as well. So you can see that the B is changed to 1, but still since A is 0, then we are not getting output, it is 0. Next, we'll change the A to 1, A to 1 and B to 0, B to 0. So 1 0 combination also, we are checking it now. So we're checking 1 0. So A is set to 1, B is set to 0, and output is still it is at 0. So when it will be 1? When both are 1. So when then again we are forcing it and we are checking the value, setting it, and we are giving the value 1. Then as you run it, now we'll be able to see that when A is equal to 1, B is equal to 1, output is also equal to 1. It's nothing but the functionality or AND gate, isn't it? So that means the circuit is functioning well. So we can also check, here we have forced the values. We can also check by using the clocks. So what we can do, we can right click on A and we can set the force value, not force. Right click on the A and select the clock and you can set the duty cycle to 50 percentage for 1 and for another signal, we set the clock with a duty a period of let's say 25 and also let's say the duty cycle is also of 25. Okay. So just however we want, you can make it out conveniently, then select OK. Then as you run this, now you'll be able to see that we are able to see the output without forcing the values, right? So here 111 it's going to be 110 100 is 0 and 1011 is 110 then 01. So all the possible combinations can be easily checked here by adjusting the duty cycle or by adjusting the period. We will be able to get it subsequently. So with this, we conclude that our functional system is working as the digital system. What we have described is working as an AND gate. Now again, I have restarted this. Then I close it because I'll go back to the quarters and I'll come back with a new setup over here. So it is actually a theoretical concept that the output you will get the output as the input changes, but there are the propagation delays also included. So in such cases, when you want to add a delay to your gate, right? Probably we can say I want to add a delay of 20 time units, 20 time units to my uh, and get response. Then I can use a delay by specifying hash 20. I can specify the uh, time delay for 20 time minutes. After 20 time minutes only, we'll be able to get our response. So what do I do now? Once again, since I modified this file and I selected, I save it again, and once again we go for checking the um, synthesis. Yes, before that, I wanted to show one more thing also, how our system interpreted our code. Okay, before I will come back to it. So, if you want to look into it, how it is interpreted. It is once again, if you want, we can run this. So, as we run this, we already checked the simulation. So now what we do here, uh, we will see that how our code have been interpreted by the system. So for this, what you do, you select the tools and select netlist viewers and select the RTL viewer. So this will tell us how our code has been translated into. So very well you can see that our code has been translated. What you have written, it is translated into a two input AND gate, which takes A and B as inputs and Z as an output. And the primitive name is A and underscore D, which is nothing but the same primitive what we have used in our uh, module A and underscore D. So that means, this system able to understand, recognize what we are trying to write. And the next concept is now adding a delay to it. So I add a delay of 20 time units to this module, that is AND gate. Then I select OK. Then click save. Then running the file once again. So I'll just double click on this. By double click on this, it will start. So as it start, initially it will be slow, then it will pick up the speed. So once again, now what we do, we are going to simulate this. So as we simulate this, go to tools, run simulation tool and select RTL simulation. So as you select RTL simulation, now the model sim has come here. So in the model sim, there is zero errors. Then we can go to library and expand the work. Right click on the and demo and simulate it. So as you simulate, so the objects are come up here, then select all the objects and add it to wave. So once it's added to the wave, here we are able to see that here. So instead of running uh, the clock, I wanted to show it with the force, then you can easily understand here. So I change the input A, no, that Z I'll bring it down here. Then A I change it to set it to 0. So please see that it is initially it is high impedance. Then I set B to 1, B to 1 here. Now, compared to the previous execution, please understand the difference what's happening here. You will be able to see that if I click on this, I click select it here, I click keep it here over there, and I select for the next transition on this particular signal. So next transition for this signal is after 20 picosecond. You're able to see that here. If I zoom in, here it shows that when it is 0, 1, it's supposed to be 0 immediately. But since the delay is introduced for a gate, it will give the response after 20 picosecond because 20 time unit we are given. So here the time unit is in picosecond. So after 20 time picoseconds, it will give the response. Similarly, let us give some other value and check. Even now we can check with 1 1 also we can check. So we will force it and we set the A value to 1. See B value is already 1. Now let us run this. So it will continually it will run. So here, uh, now here if you look into it, The at this place itself, one A is one, B is one, right? And it's supposed to be Z is uh, one. But here what happened? Z is zero. Why? The delay is introduced here. So when you will get our Z output, actual output after the delay, after the delay. So it's supposed to happen here at 100, but now it's happening at 120 picosecond. Right? So that's how we can add a delay to our gates as well. So that's mainly a propagation delay. So time taken for the output to see the changes in the input. So now come back to our quarters once again, and we will run our netlist and check it out. So how it is interpreted. So once again, I open the netlist viewer here. So you can see that you will not be able to see any additional changes over here, but instead you will be able to see the previous concept, previous schematic only, where you have an AND gate. It's called AND underscore D, two inputs A, B, and one output Z. Then where is the time? No, that is the characteristics of a gate that we can't do anything. It's just a gate time delay that we are introduced to the this setup. Okay. So this is what we call it as a gate level modeling. Okay.